The question says that three charges Q1 is equals to three charges Q1 is equals to Q1 is equals to 3 nodal column. Q2 is equals to 4 nodal column. Q3 is equals to 5 nodal column. Therefore, analysts, the question still continue and said that are located at different corners of an equilateral triangle with side 10 centimeter. Now, with side 10 centimeter. Now let's take that now. Assuming we have our equilateral triangle, our equilateral triangle is a type of triangle where all the sides are equal. All the sides are equal. And therefore, it means this is 10 centimeter, this is also 10 centimeter, and this is also 10 centimeter. So now let's locate our charges on this equilateral triangle because it has 3 points. This is point A1, another point, another point. So now let's continue this. Now at this point here, it says that find the total charge on Q3. Find the total charge on Q3. So let's assume this is our Q3. So this is our Q1 and our Q2. Find the total force on Q3. Find the total force on Q3. So at this point here, remember that we are looking for force, and formula for force is F is equals to K Q1 Q2 over R squared. So with this, we must bring out all our data first before we start solving this. And our data here, what is missing? There is Q1, Q2, all the cubes are here, but the distance, we have our distance here. Our distance R is equals to 10 centimeter. So this 10 centimeter now, we need to convert it into meter, meaning we are going to be having it 10 divided by 100, which is going to give us 0.1, which is also the same as 1 times 10 raised to the power of minus 1 meter. Now, at the continuation of this, we also have what is our K. Our K is constant, which is equals to 9 times 10 raised to the power of 9. 9 times 10 raised to the power of 9 Newton meter square per column square. That is our K. And we move further, we discuss what is the meaning of our charge. Our charge here, we have it as the same as this. We should not forget this particular diagram. Our charge should be what? 3 times 10 raised to the power of minus 9 coulomb. Our charge 2 is equal to 4 times 10 raised to the power of 9 coulomb. Then Q3 is equal to 5 times 10 raised to the power of 9 coulomb. So with all this information given to us, let's draw our equilateral triangle. We have our equilateral triangle this way. Just a little one, Q3, Q1, Q2, 10 centimeter, which is now 1 times 10 raised to the power of minus 1 centimeter, and it happens to be each of them is 1 times 10 raised to the power minus 1 meter. Then our force, the force between Q1 and Q3. You see, we need to look at the force between Q1 and Q3, which we are going to have as F13, meaning the force between Q1 and Q3. So we are going to have it as QK, which is our constant, Q1, Q3 over R squared. So we are going to have this as 9 times 10 raised to the power of 9 multiplied by our Q1, remember our Q1, which is 8 times 10 raised to the power of 9. which is 3 times 10 raised to the power of 9. So we have it as 3 times 10 raised to the power minus 9, 3 times 10 raised to the power minus 9, multiplied by our Q3, which is 5 times 10 raised to the power minus 9, all over our rate, our distance. Our distance is 1 times 10 raised to the power minus 1 all squared. So we're going to compute this. We're going to be having something like 9. This is very easy, please. 9 times 3, which is 27. 9 times 3, 27 times 5. We're going to have it as 135. 135 times 10 raised to the power of 9, this very 9, minus 9. Then we also have minus 9. All over 1 squared is something as 1 times 10 raised to the power of minus 1 times 2, we have minus 2. So therefore, when we divide this, we're going to get 135 times 10 raised to the power of 9 equals to this, we have minus 9 left. Minus 9, this very division brought about minus, then we now have minus 2. So therefore, we're going to have it as 135 times 10 raised to the power of minus 9 plus 2. We have it as 135 times 10 raised to the power of minus 7. So at this point here, let's put it in a proper standard form. In the proper standard form, we're going to have it, finally we have 1.35 times 10 raised to the power of minus 5 Newton. Because we add 2 of the 0 here, we're going to add 2 of the 0 to 7. So we add 2 of the 0 here, we take our points in 2 places, which is 2 places plus 2 here, we're going to have this. So therefore, the force of attraction between Q1 and Q3 at 3, we have it as 1.5 times 10 raised to the power minus 5. Let's keep it this way. That our F13 is equals to 1.35 times 10 raised to the power of minus 5 Newton. Q2, Q3. Now, let's take this. What is our K here? Our K is constant. 9 times 10 raised to the power of 9 times our Q2. Q2 is equals to 4 times 10 raised to the power of minus 9 times our Q3, 5 times 10 raised to the power of minus 9, divided by our distance, which is equivalent, is the distance is equal on each side, which is 1 times 10 raised to the power of minus 1 all squared. So at this point here, we have 9 times 4 times 5. This will give us 180. 9 times 4, which is 36, times 5, which is 180, times 10 raised to the power of 9 minus 9 all over 1 square will give us 1 times 10 raised to the power of minus 1 times 2 will give us minus 2. And when we do this, we are going to have this, we cancel this, we have 180 times 10 raised to the power of minus 9 all over 1 times 10 raised to the power of minus 2. So 180 divided by 1, we have it 180 times 10 raised to the power of minus 9. So minus 2. This division brought about 1 minus, then we have minus 4. 2, yeah. So minus 2 will give us plus. So therefore, we're going to have it as 108 times 10 raised to the power of minus 7. Let's take this to the standard form, proper standard form. I'm going to have it as 1.8 times 10 raised to the power of minus 5 Newton. Now, the question here says that find the total force on Q3. Find the total force on Q3. Remember that our force on 2 and 3, when the force, this is our force on charge 1 and 3, this is our force on charge 2 and 3. So here we got 1.8 times 10 raised to the power of minus 5 Newton. So please let's take away this. Our total force on Q3 is therefore F13 plus F23. So therefore we're going to get 1.35 plus 1.35 times 10 raised to the power minus 5 plus 1.8 times 10 raised to the power minus 5. So when you plus these two together, we get to 3.15 times 10 raised to the power minus 5. So this is our force, the total force on Q3. But the question number 2 says this. The question number 2 says the total electric field at Q3. The question number 2 or the B part says the total electric field at Q3. So the total electric field at Q3 is equals to, we remember what is our electric field? Our electric field Q, let's make this one to be B. Electric field Q is equals to force divided by charge. Force divided by charge. And at this point, remember, we know our force. Our total force is 3.15 times 10 to the power of minus 5 divided by the charge on Q3. Our charge on Q3 is 5 times 10 raised to the power of minus 9. So at this point here, when you say 3.15 divided by 5, 0, we're going to get 0.63 times 10 raised to the power of minus 5. Then this minus 5, this division brought about minus, then we have minus 9. Minus times minus will give us plus. So therefore, our final answer here will therefore become 0.63 times 10 raised to the power of plus 4. So therefore, we can still add the standard force to become 6.3 times 10 raised to the power of 3 Newton per coulomb. So that this is our final answer. So guys, support the channel by subscribing and stay tuned for more of the exercise that we are going to be uploading